everyone. We are picking up where we left off with lesson 9-6 from Algebra 2. So this is a lesson on complex numbers, and now what we're kind of leaning into is how complex numbers interact with polynomials, specifically in terms of what's called complex roots. So we've been talking about factoring a whole lot, and I'm giving you this expression right now, and I'm telling you to factor it. And I'm hoping that you're remembering all of the times before when I've said, wait a second, we're not allowed to do that because that's a plus sign. This almost looks like difference of two squares, but it's not because it's addition. Okay? So if I had handed you this at any point up until now, you would have told me that that's impossible, that that can't be done. What changes the game is when I say over the set of complex numbers. That means that I'm no longer restricted to only using real numbers in my factors. I can use complex or imaginary numbers now as well. So here's how I want us to think about this. If I want this to be a difference, a true difference of two squares, I could take that plus sign apart, right? And think of it as x squared minus -9. Now that's a difference of two squares. This is a perfect square, this is a perfect square. Okay, so when we factor this thing, we know that we're going to split it into x and x. We know that because it's a difference of two squares, I'm going to have one plus and one minus. Now the question I'm asking myself is, what is the square root of -9? So if it was just a 9, you would tell me 3. Because it's -9, now that's going to be a 3i and a -3i. Okay, you've never seen that show up in factors before, but now with complex numbers, now I can make factors with imaginary pieces in them. Okay, this is kind of getting ahead of myself. This is kind of leading into the next lesson. But what this actually means is that we have what's called complex roots. We have imaginary roots on this function. We have a root at 3i and we have a root at -3i. Those are roots that you can't see on a graph. And I'm going to talk way more about that in our next lesson. But the imaginary roots, they're not the x-intercepts. You can't point to them on a graph, but they are considered to be roots of the function, because if I plug 3i in here for x, it is going to work out to be a 0 of the function, okay? So for now, that's all that question asked me to do, is the factoring, but just wanted to, again, reiterate that relationship between the factors and the roots. So now let's look at example 5, and I'm telling you to solve this thing. And my guess when you look at this thing to solve is your first instinct would be quadratic formula, okay? And I'm with you. That's what I would do too. Your other option would be factoring, but factoring doesn't look real pretty because I don't have many things that multiply to make 13, right? I can't multiply to 13 and add to make 4, but I can solve this thing with quadratic formula. So let's give that a try. So program quadratic formula. My A is 1. My B is -4, my C is 13, and I get this error message, non-real answer. Non-real, that's the same thing as imaginary, okay? This function has imaginary roots, so quadratic formula can't find them unless you tell your calculator that imaginary roots are okay. So here's how you do that. I'm going to quit out of there. I'm going to hit this mode button, and I would imagine that for most of you, down here toward the bottom where you have this option of real or a plus bi, or this is like polar coordinates, you don't have to worry about those, but you're probably all set to real numbers. That's telling your calculator to restrict everything to the land of real numbers. So if you want it to give you imaginary solutions, you kind of have to give it permission to do that. And you can do that by going down here and choosing the a plus bi. And that's making the imaginary numbers or the complex numbers fair game. So I'm going to quit out of here again. I'm going to run that quadratic formula program one more time. So I'm going to go 1, -4, and 13. And this time it is going to give me roots. It's going to give me imaginary solutions here at 2 plus 3i and 2 minus 3i. So from quadratic formula, with my a plus bi turned on, my roots are at 2 plus 3i and 2 minus 3i. And I know that's weird to think about as roots. And again, if I were to graph this thing, I wouldn't see any x-intercepts at all. Okay, in fact, let me do that real quick. Under y equals here, x squared, whoops, what am I doing? X squared minus 4x plus 13. And what you'll notice, it's going to be hard to see here, let's see, is my parabola is kind of floating up here in thin air. I don't see any roots. I don't see anywhere where it crosses the x-axis. When that happens, that means I have imaginary roots at play. And again, we're going to talk way more about that in our next lesson. But what I want you to be able to do today is still follow that same procedure we used with the factor theorem before. If I know that these things are the roots, I can factor this thing, and really this should give me permission to use the complex numbers. Because if I just handed you this thing and said, hey, factor this, you would not be able to. But when I give you permission to use the complex numbers, now I can say, well, I found my imaginary roots, and so I can write this as x minus 2 plus 3i and x minus 2 minus 3i. Remember, the factors are always x minus whatever the root is. I think sometimes we see this and this already kind of looks like a factor, and so we forget about that x piece. But we still want to write it as x minus this root and x minus this root. Okay, so this is factored using complex numbers. Now, if I had to actually go through here and like multiply these back together, it would be a whole hot mess. Okay, but if I did it successfully, it would turn back into this function. Okay, I won't ask you to do that. But if you're trying to check your answers, just know that you could. You just have to be really careful with it. Okay, I think that's it for me for today. Like I said, we did a lot of things today that are kind of setting up for the next lesson. So, you know, for right now, as long as you can manipulate all those imaginary numbers, you're going to be in good shape. And then when I see you again next time, we will talk about how this relates to our polynomials and our graphs and the factor theorem and all sorts of fun things. So, all right, that's it for me. Have a great day.